Okay, let's look at our second exception for integration by parts. And here's an example here. Let's try the integral of e to the x sine of x with respect to x. And notice that this is an integration by parts. How do I know that? Well, it does not fit a basic rule. None of our basic rules have e to the x and trigonometrics together. We cannot do any type of u substitution. It's not a trigonometric integral or any of the others. It's actually two separate and distinct functions which cannot be combined. As with the other exception, we cannot use a table here. We're going to have to do this the long way. So I'm going to pick u to be either piece of this, and you can decide what the overall goal, and this should be in your notes, is that we're going to perform integration by parts twice. By the second time we do we're going to get back the integral we started with, and then we can do some algebra to work this out. Whatever you start with as your u, that's the thing you're going to differentiate. So just make sure you stay consistent. In other words, if you pick u to be the exponential part in your first integration by parts, make sure you pick it the same way in the second. And the trigonometric then will be the dv for both. So I'll pick u to be e to the x, which means the dv is everything else, which is the sine of x dx. If you prefer to do it in the other direction, that's fine. You can let u be the sine of x and your dv be e to the x. It's absolutely up to you. Makes no difference in the end. Well, for me, that's my u. So du dx, which is the derivative of u with respect to x, is e to the x. And multiplying both sides by dx, I get du is equal to e to the x dx. I'm also going to need my v, which is the integral of the sine of x dx. And so that is going to be equal to minus the cosine of x. That's kind of one of the things people typically don't care to integrate trigonometrics because it's hard to remember which one's which. It flips from what we do when we differentiate. But regardless, let's go back up and look at what we have now. So we see that the integral of e to the x sine of x dx is going to be equal to, and let me write it up top here so I know what I'm looking for, uv minus the integral of v du. So let's go ahead and put in our stuff here. So we're going to have u times v, and u times v is going to give me a negative e to the x cosine of x minus the integral of v, which is a negative cosine of x, times du, which is e to the x dx. Let me just do a little bit of cleaning up on this here. This is going to give me a negative e to the x cosine of x. Those two negatives will become a positive, and I'll get plus the integral of e to the x cosine of x dx. And so what I've done here is to create a second integral. And this integral, again, let's look at it and see what we have. No basic rule. No u substitution. As a matter of fact, it looks like we have another integration by parts, which is what I would expect. Once again, I'm going to let u be the exponential part since that's the way I chose it the first time, which means the dv is the trigonometric part or everything else. Then based on my choice of u, I will once again do just like I did up top. Du dx is e to the x, so du will be equal to dx. And then v will be the integral of the cosine of x dx. And the integral of the cosine of x is actually the positive sine of x. Now, I like to rewrite the whole thing when I'm doing this, so let me go back up and see what I have. I started with the integral of e to the x sine of x dx, and that was equal to minus e to the x cosine of x, plus, and now once again I'm going to use uv minus the integral of v du. So that's going to give me a plus e to the x sine of x minus the integral of, I lost my e to the x on this one here. Sorry about that. And so it's going to give me minus the integral of v du, which is going to be e to the x sine of x dx. And as I said in the beginning, when you do this, you're going to see that after you've done integration by parts, you're going to get the same integral that you started with. And it's at this point that we do a little bit of algebra. I want to move this negative e to the x sine of x over to the other side, and so I can do that by adding an e to the x sine of x with respect to x, and I can do it, since it's an equation, as long as I'm doing it to both sides. Now, when I do that over here on the right, it's going to go away, and I'm going to get 2 times the integral of e to the x sine of x dx is equal to a negative e to the x cosine of x plus e to the x sine of x. And then, of course, we just need to get rid of the 2, and we can do that by simply multiplying both sides and distributing through a positive 1/2 here. And so we get as our final answer that then the integral of e to the x sine of x dx is equal to a negative 1/2 e to the x cosine of x plus 1/2 e to the x sine of x, all plus c.